we start how we see data preparation. Okay, we will show you how you can prepare data from scratch. Okay, so previously we have seen two scenarios, right? Land management scenario, and the other is the operational management scenario. So now let's see, let's try to change or edit the existing management. We say corn no-till dry land, and we'll see what does this corn dry land no-till operation looks like, and then modify with and without fertilizer. Actually, the one we ran it before was with fertilizer. Okay, but now we'll see how we can remove the fertilizer application and see how does the result, especially the crop yield result, is changing when we use no fertilizer. Okay, so you can go here again, edit all other files. This time I will be going to the management. Previously for the land management, we were using watershed editor, right? So now we use the management. So this dialog box will appear, and we say edit existing budget. So these are the different operations that we have, but we used corn, dry land, no-till, right?
Yeah.
For our case, corn, dry land, no-till. And if you see, this is the operation file. This is the operation file. So there is, I'm not sure if you look from behind, there is a fertilizer and a pesticide applications to this corn, dry land, no-till. So this is the rate of application. Okay, and as you can see from this type of application, we have pesticide application twice in this year and month and day, and we have fertilizer application in February 1 twice. So there are two fertilizer application. One is a nitrogen fertilizer, the other is a phosphorus type of fertilizer application. So these are the rate of application in kilogram per hectare. And another pesticide application occurs here in March. Okay, and then the other operations are harvesting and honing operation, plow, and kill operation. So you plow and plant the corn, and finally you harvest and kill, meaning if you kill, it will not regrow, you will be planting again. But for those of you, if you are interested in a type of plant that regrow after you harvest, you do not use kill. And so now we are interested to just remove the fertilizer application for this. So just highlight the fertilizer application and delete row. Delete row. Yes. So one of the fertilizer application is deleted, and also do the same for the other fertilizer application. Highlight it and delete the row. Yes. Now the operation is modified. You can save it Once you delete the two fertilizer application, you can save it and go back. You want to save changes to this version? Yes. And we need to make sure this core dryland is selected in our management. Remember, we modified the core dryland no-till practice. And we need to make sure from the watershed editor uh, in the sub area that we have selected this specific management core dryland no-till. If it is another one, we will not see any changes in our simulation. Okay? So we select the English tab and edit the sub area, and you can see the operation. It is called dryland conventionality. This is for the second scenario, if you remember. What we have modified now is called dryland no-till. So we'll get back to the core dryland no-till. Core dryland no-till. This is the one which is modified. And click yes and save changes. Now we have modified the operation of core dryland no-till, and we have selected our simulation to use this specific operation. IOPS here.
IOPS, okay.
The one that we were using earlier. Now you can go back until you come up to the first window page. Then you select the watershed and you select the control file you're running. Okay, so once you run it, you do the same thing. You go to the WinApex folder, Apex Pro, and copy everything. And come back to your folder, and let's create a new folder called no fertilizer. No fertilizer. And you can paste it there. From the file type ACY annual crop yield, just open the annual crop yield file. And you can see from this result
APS
ቪው ላይ ገብተህ ዙም
APS
ቪው ላይ ገብተህ ዙም ኢን የሚላል ዙም አለ ከዛ በኋላ ዙም ኢን ያ ከዛ በኋላ ኮንትሮል ዙም ኢን በለውና ከዛ በኋላ ኮንትሮልን ይዘህ ስክሮል ከዛ በኋላ ይሄንን ኮንትሮል
Okay, that's good.
Yeah.
Now you can see this is the yield, and now you can see we have a number of nitrogen fertilizer days. Phosphorus, no, I don't see much phosphorus uh, stress. That might be because of the soil characteristics. We removed both phosphorus and nitrogen fertilizer from the management, but the only stress that I can see is the nitrogen stress. So let's move this crop yield. So remember, this in the SY file that we have seen earlier. I have copied the baseline. That was with fertilizer application. Okay, and it was with fertilizer application. Now without fertilizer, let me copy the yield. You can copy in similar fashion. Can you see also the mean yield over these 20 years? The dry yield is 5.9, but 4.9 without fertilizer. 1 ton per hectare yield, dry yield, is reduced because of this nitrogen fertilizer. And you can add the nitrogen fertilizer days, the nitrogen stress days, to see how it is behaving. Copy and move it to nitrogen stress days. Let's also move the water stress days. These are also some value. Let's move the potassium and phosphorus stress days. And temperature stress days. And you can see the yield difference. This year, yield, the blue color is the yield with fertilizer, that is the baseline. Without fertilizer, you can see that since the start of the simulation, it was somehow the same, but after some years, it loses its nitrogen from the soil and being degraded. And without fertilizer, gives you a very reduced yield. So this is without fertilizer, and this is with fertilizer. And you can see the highest stress. You can also plot together. This one is a plot with the phosphorus uh, stress days. You can plot the nitrogen stress days. Okay. And see. So if the nitrogen stress keeps increasing as the time goes, and that is the reason for the decline of the crop yield. Is that clear? Or does Fatih need to do it one more slower?
Sorry, I want to watch so go on.
Uh,
I have a small problem
okay. So if you like to see it, just run your model and see the difference in the plot by yourself for a couple of minutes, and then I will round as well. And then we'll start data preparation, right? Fat? Yeah. Okay, I'm come.
Exercise. So, as we've been discussing from the first day, we need some key data sets that are we all here?
Would you please listen to her and then
Should I talk in Amharic? So, we need some key data sets to drive our model. As you saw in the model, some come with data sets, but some we need to provide. If you don't feed it with that information, you cannot make useful analysis. So when you look at the folder that we had, we have some very useful information that we are going to use to help us to generate the data sets that we have. So basically, we need data on the daily time scale, climate data. So you need information on rainfall, temperature, solar radiation, and so on and so forth. And then also you realize that sometimes you may have a watershed, although there is a gauging point you can access data, sometimes the data is very bad and it's like you can't even use it for anything. So, so when this happens, you might need to have a sort of a weather generator which will serve as a basis for creating data sets for when you need it. So number one, we need data on the daily time scale. We will see them in details. Number two, what if you don't have data sets? It's true now there are several data sets, remotely sent data. One of them that we normally use is the CFSR data, but sometimes even after comparing it with station data, you realize that the gaps are still too wide. You need to do some bias correction and so on and so forth to use. So sometimes you can have observed data, but it's not good enough. It has gaps. So you can generate your weather generator so that you can have a base within which to generate daily data in case you don't have observed data set or the quality is not so good. And then when it comes to the soil data set, sometimes, I mean, we know that field work is very expensive. You can go to the field, you basically can use sieve analysis to look at the different soil texture types. But when it comes to the details of the soil analysis, sometimes it's too expensive that our laboratories cannot cater for them. So we will go through these three different types of getting information based on the add-ons that we have to be able to see how we can generate data for inputting into the WinApex. I hope it's clear. Okay, so the first one we will look at is the uh, weather data. Yeah. Okay. So the key thing to remember is that WinApex uses data on a daily time step, right? So imagine that we have obtained our data sets from wherever, whether remotely sent or from our meteorological offices or from wherever. So these are the key daily data that we need for WinApex. So you need information on the latitude, longitude, elevation, and then you need these key data sets. So you realize that if you don't have any of these, then you have to find a way of getting it. And then this has been arranged very nicely for the purpose of our study. I don't know how many of you have obtained data directly from the Met Office before. it's sometimes difficult to even arrange, right? So you may have to process it in this manner before you transfer it into the tool, which will help us to generate it in the form that the WinApex can assimilate. So let's assume that we got our maximum temperature, minimum temperature, rainfall, relative humidity, wind speed, solar radiation in a haphazard manner. So we need to first of all structure it. So you have the date here, you have all these from the beginning until the end. So what we need to do now is that in this form, the program cannot accept it. So what you have to do is to go into your software data set. So there is a folder called Apex Daily Input Preparation. Okay, so this is what is going to help us to prepare our data in the format that the Apex can take. I don't know how many of you studied this file structure when we had it. You see here that there is ET001 DLY, there is ET002 DLY. One key thing that you would want to ensure is how you name your files or your folders. Otherwise, you'll be confused. It's necessary to have and to keep a structure of how your programs and folders look like so that you don't get confused. For example, if you don't name your scenario 1 well, scenario 2 well, your baseline well, you leave the program, you go to the field, you are busy during the day, you come back and you ask yourself, what is this? So naming of files and studying your structure is very important. I brought us here so that you will know that there is a file named this and a file. So we have 001 and 002. So when we come here, let's see what this will give us or take us to. Okay, I'm supposed to be patient. Okay, so this is a form of, can I call it a macro? Yeah, which has been designed already. You don't need to tamper with this side. The only thing that you have to touch here has been highlighted in yellow for you, and that is the beginning of the date. So assuming that you want to start your simulation from 1970 something, so you can just change it here and it will apply throughout the rest of the date. So when you come to the right side, that's the only thing you have to touch, nothing else, because it's been a series of underground tasks going on in there. This is the area where we can play. Okay, so here we have the year, we have the month, we have the day, solar radiation, maximum temperature, minimum temperature, rainfall, humidity, wind speed. So in case you have your data set and it's mixed up, like you have wind speed here, you have this here, you have that here, be sure to align it with this one here so that you don't get confused. So what you will do is that, let's say you've been running your model since 2 years ago or 3 years ago and you have new daily data sets and you want to process and run. So to make our work easier, we don't have to change anything here. So this one is starting from 1st January 1980. When you look at the data that we have already, it's the same. It's the only difference is the values. Okay, so this one here, you realize that there are different values. So we have to copy and then paste. So you can simply use your Control Shift down arrow. Yes, and then you Control C. Okay. So just paste. So you see that automatically the values have been picked up here. So remember I told you about naming files. We would want to give it a unique name so that we can identify it and then use it for the purpose for which we are generating it. So at this point, please watch. We are in sheet 1. I just give it a right click and then view code. You see that because in this software we already have ET001, automatically the new name which has been assigned is ET002.
Yeah.
So if we don't change the name, what can happen? Remember the main Apex Pro file structure. Remember there is already ET002.
Yeah.
So now we'll be confused which is which. So we can name this maybe ET003. Close this, close this, and then you export your file. Then let's check and see if our magic has happened. I hope so. Yes, our magic happened. So Apex can accept this. Are we good? I should go over, right? Okay. Okay, so we are going over.
You know,
From where we get ET history. Where it is okay in the folder.
Where did I get the okay. So should I should I start from the beginning or continue from here? Start from the beginning. In my country, you will say the whole show. So that we have the same thing. Okay. So what I've been saying is that we need daily data sets, okay, for our WinApex model. Maybe we have it, maybe we don't have it. If you have it from the meteorological office, mostly it's, I remember 1st January 1981, 2nd January 19, like it's like this. And then they don't, if it's 29 days, if it's 30 days, if you don't take care and you want to use macro to align it like this, you may have a lot of errors. So data preparation is a major step that you have to go through before you input it into your model. So for our case, we are assuming that we have already gotten the daily data sets that we need for our exercise. So in our folder, where can we find this? So we go to input data. If you want to set up your own watershed and do your own analysis, and it's not in, is it Dambuya we call it, you will have to source for your own data. But for us, we are lucky that we have the data sets that we need for our model to run. So the main data set that the program needs is solar radiation, maximum temperature, minimum temperature, rainfall, relative humidity, wind speed. And this is how it's supposed to be arranged so that you don't confuse the macro, because the macro that has been built for us to make our work easier is in this format, and this is the format that also WinApex accepts. So be sure to align it this way. So once we get here, we need to track the software that we are going to run with it, right? I don't know if it's possible for us to manually arrange this in Notepad++. I know that there will be other ways where we can get it in the format that we want. But to make our work easier, this macro exists. So we go back, we look for our software folder. We are trying to prepare our input weather data. So we look for the Apex daily input data preparation folder. This is the macro that has been prepared to help make our work easier. So, so we are not allowed to touch anything in blue because of the calculations behind the macro. This is our playing field. Okay. Assuming our data set starts from, let's say, 1st January 1962. Let's see. Oh, 1962. Okay. So you see that by changing the first date, automatically the rest change. But in our case, we don't have to change the date because the date here is already aligning with our simulation period. So I'll just change this back to 1st January 1980. So when it comes to the right side, the yellow highlight is the only thing we can change. Then when it comes to the left side, it's been arranged in a similar manner as how our data set has been arranged and how the WinAppex will accept it. So we need to replace the data set here with the new data set that we want to run. So select the row, Control Shift down arrow. So it takes us from the beginning to the end, Control C. And then we come to our macro, then we paste. Okay, so now we need to give it an identifier. We want to be able to identify it whenever we see it and not get confused. And I'm saying that when you go into the main Apex training folder, you will see that there are already files ET001, ET002. Okay. So, and when you look at the weather generation, when you look here, you will see that we have ET001. So when we just go ahead and export our files, we are from ET001. Automatically we'll have ET002. But there is already ET002 somewhere in our main folder. We don't want to get confused. Which is why we want to give this whether new data arranged in the format that we want a unique identifier. So you go to sheet 1, we are working in sheet 1. If it's sheet 2, you go to sheet 2, but we are working in sheet 1. So you right click it, and then you go to view code. You will see that automatically it was going to call it ET002. But we want to give it our own name. We can make it ET00 AMU. Is it acceptable?
It needs to be 6 digits.
6 is 1, 2, 3, 4, 5, 6. So yeah,
That's
so
all.
ETAMU2. But let's make life easy for ourselves. ET003. Three. And then you close it. Close the main. You close it. And then you close the main area too. And then you export files.
Macro enable save ብላችሁ ከዛ በኋላ ደግማችሁ እዛ enable
Do we all have ET003?
yeah I have Jika hospital kode ya Andayo.
Is there any questions regarding the data preparation and concept calculation? And any questions? Concept calculation? Okay, I'm asking one question there. If you don't have question, what will you do if you whether still have missing value? Feeling? How do you feel? Okay.
100 supir begitu.
Yeah, you can't, yeah, you have two options here. You have two options. One is if you can't fill it, there are many ways to fill the missing values,
Ya,
right? So you might also use satellite data in case of missing values. But for this case, you can also provide 999 values.
negatif
Yeah, 999 values. So allow the model to generate using the monthly weather generator. Okay. But in order to have the monthly weather generator calculated, you need a station without missing data in order to compute the weather generator. Okay, another question. Another question that
exactly የተማርኩት